W index is just a refinement of the phi index. Find out the minor tweaks in using this method to determine the constant infiltration capacity. Welcome to hydrology. For a certain water basin, if precipitation occurs, there are water losses and possible runoff if the rain is ample enough. In order to compute for the runoff, we need to make the infiltration constant. This is done in three methods. The first is the phi index, with the concept that the rainfall volume is equal to the runoff volume. The second is the F average method, taking the average infiltration loss throughout the storm duration. The third is W index, which takes the infiltration rate during the time the intensity is more than the infiltration capacity rate. The W index is another method, very similar with the phi index. This method takes into account the initial losses in solving for the infiltration. Mathematically, W index is the precipitation less the runoff and the initial losses, all over the duration of the rainfall excess. That is, W is equal to P minus R minus I sub A all over T. This equation is just like the phi index, only with initial losses subtracted. Graphically, this is subtracted from the first entry. Just like the phi index, there are possibly multiple iterations when looking for the W index, as the procedure is also by trial and error. Every step from the phi index is also observed for the W index, with just an additional step of incorporating the initial loss in the equation. The first example for this index includes a recorded storm over a catchment area. With a given total direct runoff of 23 millimeters, we are to determine the W index assuming initial abstraction is 2 millimeters. This index also uses the hyetograph, which means we are also to look for the rainfall intensity. The first step is to place pulse numbers for each entry, then take a closer look at the provided parameters. There is a column for the accumulated time from 0 to 5 hours, then rainfall depth in millimeters. Having fluctuations in the rainfall values, we can deduce that this is incremental rainfall. And since intensity is incremental rainfall over incremental time, we need to convert time. The first is 1 minus 0, giving 1. 2 minus 1 is also 1. 3 minus 2 is 1. Also 4 less 3 is 1. And the last is also 1 from 5 minus 4. With both parameters as incremental, take the rainfall intensity by dividing the depth by time. Like 8 divided by 1 is 8. 15 over 1 is 15. 12 upon 1 is also 12. Then 10 divided by 1 is 10, with 5 over 1 as 5. You can plot the hyetograph in order for you to see the areas of bars needed in the solution, or just take the area of each bar, and that is by taking the interval time multiplied by the intensity of rainfall. That is then 1 times 8 giving 8. Then 1 times 15 is 15. The third entry is 1 times 12, which is still 12, followed by 1 times 10 giving 10. The last entry consists of 1 and 5 resulting to a precipitation of 5. So far, all we did are still part of the solution for the phi index. But in order to proceed with W index, take the initial entry and then subtract the initial abstraction. For this example, it is 2 mm. The next column for precipitation in W index then starts with 8 minus 2, which is 6. And the other values are taken as they are, 15, 12, 10, and 5. With all parameters prepared, have the first trial in solving for the W index. Consider all the 5 pulses, thereby using t of 5 hours. From the equation, we have runoff of 23, and the precipitation P is the summation of the values in the last column. P is equal to 48 mm. So the function then is 48 minus 5W is equal to 23. Arrange terms to have W as equal to the quantity of 48 minus 23, then divide this by 5, which then gives 5 millimeters per hour. Comparing the index with the intensity, pulse 5 then will not yield any runoff because the intensity is equal to the index. Work on the second trial, this time taking out pulse 5, making t equal to 4 hours. With the same function, we plug in P as the summation of the remaining precipitation, which is 43 mm. So the function becomes 43 minus 4W as equal to 23. W then is 43 less 23 all upon 4, resulting to 5 millimeters per hour. Compare W index with the rainfall intensities, and it is observed that there is excess rainfall from each pulse. So we consider W index as 5 millimeters per hour.